Hi, let's get started on this topic in mathematics, which is all about graphs. So, what exactly are graphs, and what do they make use of, and how do we ensure we make use of a book like this? This is a graph, right? So, how do we make effective use of this particular book, and how can we interpret what has been plotted on a graph? So that's what the point of this class is for, and that's what we are going to be dealing with. But first things first, let's start from the basics. What exactly is a graph? So a graph sheet a graph is basically a tool for visualizing algebraic equations. So let's call it like that. So we say it is a tool for visualizing algebraic. Let me not just say algebraic. Let's just call it okay. A good way to summarize that is functions. So a tool for visualizing functions. So at this point of your mathematics, I believe you should be quite familiar with what functions are, but just a tool, just to check it again. A function is basically a little bit of a transformation that we apply towards an input. So let's use this to visualize what a function is. So let's call it a transformation. So we have an input that goes in, and then we have an output that comes out. So output. So that is what we have as functions. So something goes in, something happens, a little bit of processing occurs, and then we have an output. So whatever does that is what we call a function. So for example, x could be an input, y could be an output, right? So we could say that y is equals to 2x. That is a function, because for any input that goes in, your output is going to be double of it, like 2 times 5, 2 times something, 2 times whatever that is your the output of that function. So that's a little bit of a transformation. So when we want to plot our function, or when we want to plot our graph now, we are basically having a way of visualizing how your input and your output of that function is behaving. That's basically what a graph is doing. We want to see, okay, if I do anything to the input, what will be the output in a way that we can see for ourselves. And that is the point of graphs, right? So as we have different kinds of functions in mathematics, we will also have different kinds of graphs as well. So because we have different kinds of functions, so the different kinds of functions we have, we have the algebraic functions. The algebraic functions are your your linear equation, your simultaneous linear equation, equation as well. We also have the quadratic equations as well. So the quadratic ones as well. Let's generalize the higher order ones as your polynomial equations as well. Polynomial equations. So your linear equations are the ones that have the highest power of x to be 1. Your simultaneous equation are linear equations that occur simultaneously. If you have something like this, say 3x plus 2y is equals to 9, 6x plus minus, let's say, 5y equals to 10, for example. This is a pair of simultaneous equation right here. But let's move on. So we also have the quadratic equations. The quadratic equations are the ones that have the highest power of x to be 2. So if you have something like y equals to 6x squared plus 5x plus 9, you're talking about a quadratic equation. The highest power of x is 2, like that. So that's a quadratic equation. So we have that going on for that. So there are some equations that have the powers of x to be higher than 2, and it could be 3, it could be 4, could be 5, could be 6, and so on, like that. So I am calling them as your polynomial equations, and I think more appropriately I should have called them the higher order polynomial equations, meaning that they have the higher orders that is greater than 2, which is the case for the quadratic ones. So in all of these cases, we have the algebraic functions, right? So apart from the algebraic functions, we could also have what we call the transcendental functions. So now these transcendental functions now, they are the ones that are beyond algebraic functions. So transcendental functions are, the word transcendental in English language means goes beyond something. So these transcendental functions are functions that are not part of your algebraic equations. They're just not easy mapping of x and y in this kind of sense like your algebraic ones. So they do something much more. So for example, are your trigonometric functions like sine x, your cos x, your tan x, and other ones. We also have the exponential functions, the natural logarithm function, and the log to, let's say, to base x function, to base 10 rather, of x, for example. So these are also examples of functions that can be easily visualized. We could visualize these functions as well by plotting them as a graph. So that's what we have in this case now. So in this first part, I talked about functions, and then your graph is basically a tool for visualizing those functions. So function is basically like a transformation that we apply to some input. Some input goes in and does some certain thing, some certain transformation, some certain mapping happens to that input. So at the output of it, we have the result or the value of our function. So because of the way it works now, because the output of our function, it depends on whatever the input is. So we usually call the x the independent variable. We call it the independent variable. Independent, meaning that it doesn't depend on anything at all. It is going to take its own value. While this y, your output of your function, it takes we'll call it the dependent variable. Dependent variable, because it depends on whatever value that your x has decided to take. So that's the idea of this particular concept. So that's what we have for functions, and we plot them out. We have the graphs for them. We can study the graphs, and it allows us to make easy ideas from easy visualization of the way the function behave. So in the next video and the ones that follow, we are going to be taking some rules on how to plot a graph, how to easily understand a graph, and other similar concepts like that. So I hope this first part was quite really understood. So yeah, let's catch up in the next part.